This is the trial exam 2019, and this is the ST&SP paper question number 1. It's got a student cycling to school, and this is a graph of their journey. It's a velocity time graph. So there's two things we need to know about a velocity time graph: that the gradient is the acceleration, because it shows the change in velocity over time, and the area underneath is the distance traveled, because that is velocity times time, which is distance. So the first question is describe the motion, so we don't have to get an explanation in, we just have to say what's happening during those stages. So for B, it shows that there is zero gradient, so there's no acceleration, so it must be going at a constant velocity. We can give a little bit more here because we can read it off, of 5 meters per second. Then during D, it's flat, so there's no acceleration, but there's also no velocity, so it is stationary. Stationary at velocity equals 0 meters per second, and that's for 2 marks. Okay, so B, it says, state how the graph shows that the acceleration for stage E is greater than the acceleration for stage A. So we'll go back and have a look. So why is section E the acceleration greater than section A? So if you look back, it's just a state question, just 1 mark state question. So we're just going to say the gradient is the acceleration. This is my shorthand for acceleration. And E shows a greater gradient. So I'm making sure I've got the points there by telling them that I know the gradient is the acceleration, so I'm comparing the two, A and E is a bigger gradient, so it must be a greater acceleration. You could have said something like the gradient is steeper as well. So now we're going to calculate the distance the student travels in the last 10 seconds of the journey. Let's go back and have a look. So in the last 10 seconds, that would be between 15 and, it actually ends there. So we'll have to have a look. So, by the magic of pausing, we've got two different shapes to work out. We know in the last 10 seconds that it's going to cover this distance plus this distance here. So I think it's actually somewhere around here. I can't do it on the screen, but you're looking for the area underneath in the last 10 seconds. Each one of these little boxes seems to be worth, each 2 of these little boxes seems to be worth 1. Because there's 10 little boxes and those are worth 5, so each 2 is worth 1. So what they have is that it's 7 times 7, which is the base of the rectangle, times the height of the rectangle, plus half times 7 times 3, which is the triangle. So then that would work out to be 49 plus 10.5. The total distance should be that. This calculation, what we would really like to see is that you're picking out the correct size rectangle and the correct size triangle. The only thing that was difficult here is working out what each one of these boxes is worth based on the scale of the graph. But you have to show that you're working out the area underneath, and this would show me the area. So we've got 1, 2, 3, 4 marks. The total distance traveled is 106.5 meters. So the average speed of the journey is 4 meters per second. So we're going to show that. So we know what we're going to try and get to. Now they're working out average speed, and we know that average speed equals distance over time. So the distance they've given us is 106.5, and then we read off from the graph what the time to travel that distance is, which if you work it out is 27 seconds. So then finally, that would be 3.94 meters per second, which is about 4 seconds. And that's question number 1.